Okay, in this video we're going to be looking at example number 5 from the 7-6 notes. We're going to be looking at solving this system of equations using the Gauss-Jordan Elimination method. So the system of equations we have here is x minus 3y equals 3 and 3x plus 5y is equal to negative 19. So the first thing we're going to go ahead and do is we're going to go ahead and write this as an augmented matrix. So the coefficients on the x for the first equation is 1, for the y is negative 3. We'll use a vertical line to simulate the equal sign, and this equation is equal to 3. The second equation, we have 3 for the 3x, 5 for the 5y, and then this is going to be equal to negative 19. The first column is going to be for our x's, so the columns is the up and down, and the second column will be for the y. The top row is the top equation, bottom row, or the second row, is the second equation. Now, the process for the Gauss-Jordan elimination is the coefficient matrix, which is the coefficients on your x and y, so that's the left side of our matrix there. We want to make it look like this. So we want to make it look like 1 in the row 1, column 1, 0 in row 2, column 1, 1 in row 2, column 2, and then finally 0 in row 1, column 2. And this is what the pattern that we want to follow. You can do other things, but you're likely to introduce error if you're doing some other pattern here. So this is the pattern we want to follow. So we get the first step for free. Notice in row 1, column 1, we already have the 1 there, so we don't have to do anything. So the next thing we want to do is we want to make this 3 in row 2, column 1, we want to make that a 0. So that's in column 1. If we're making a 0 in column 1, we want to use row 1. Okay. The opposite of 3 is negative 3. So we're going to take row 1, so we're going to use row 1. We're going to take row 1, we're going to multiply that by negative 3, and then we're going to add that to row 2, and that's going to become our new row 2. Okay. And if you're just doing regular Gaussian elimination, then this step will be the same here. And you can do this mentally, or you can write out a little table. I have a tendency to write out a little table. So negative 3, row 1, and then we're going to add to that row 2, and that's going to give us our new row 2. So I'm going to take the negative 3, and I'm going to multiply it by the 1, the negative 3, and the 3 here. So negative 3 times 1 is negative 3. And then negative 3 times negative 3 is 9. And then negative 3 times 3 is negative 9. Okay, row 2 is 3, 5, and negative 19. And then we're going to go ahead and add that, and that's going to become our new row 2. So negative 3 plus 3 is 0. 9 plus 5 is 14. And then negative 9 plus negative 19 is negative 28. So after we perform that row operation, the only thing that's replaced is row 2. So row 1 is unaffected. So row 1 is still row 1, which is 1, negative 3, and 3. Now our new row 2 is right here, is 0, 14, and negative 28. So we're going to go ahead and put that in there. So we've completed the second step in the Gauss-Jordan elimination. And the next thing to do is we want to make a 1 in row 2, column 1. So we're going to make a 1. Usually what we want to do is we want to multiply by the reciprocal of the whatever we want to make a 1. So we want to make 14 a 1, so we're going to multiply by its reciprocal. Now there's another way to think about that. Instead of multiplying by the reciprocal of 1 over 14, row 2, so the reciprocal is 1 over 14, we're going to multiply that by row 2, and we're going to replace row 2. Alternatively, if it helps, you can always think of it as divide by that number. So take row 2, we're going to divide by 14. Why 14? Because that's where we want to make the 1. So we want to make this 14. We don't want to make that a 1. So we're going to divide row 2 by 14. And that's going to become our new row 2. When we perform this row operation, we're not replacing row 1, so row 1 is unaffected. And then we're going to divide each entry of row 2 by 14. So 0 divided by 14 is 0. 14 divided by 14 is 1. And negative 28 divided by 14 is negative 2. Okay. All right, so that completes the third step in our Gauss-Jordan elimination. this would be the last step for Gaussian elimination. So, you've probably seen videos where they do back substitution. Some of my videos use the back substitution technique, so I'll briefly mention it here. So the second equation is y equals -2, and then we back substitute that in, and so that works out nicely. We're going to do the full Gauss-Jordan elimination. And so the last step we want to do here is we want to make where this -3, we want to make that a 0. Okay. Now that is in column 2, so that's in column 2. If we want to make zeros, we've got to figure out what column it is. So this is column 2, so we're going to use row 2. The opposite of -3 is +3. So we're going to use row 2. We're going to multiply row 2 by the opposite of -3, which is +3. So we're going to be multiplying row 2 by 3, and then we're going to add that to row 1, and that's going to replace our row 1. So we'll go ahead and write that out here. So 3 row 2, so 3 times 0 is 0, 3 times 1 is 3, and 3 times the -2 would be a -6. Row 1 is what we're going to add to it, which is 1, -3, and 3, and then we'll go ahead and add that to become our new row 1, which will be 0 plus 1 is 1, 3 plus -3 is 0, that was what we're after that 0 there, and then -6 plus 3 is -3. So row 2 is unaffected, so when we rewrite our matrix, the bottom row is unaffected, and the top row is now 1, 0, and -3. Okay, so the bottom equation is 0x plus 0y equals -2. So because it's 0x, it's just y equals -2. And then we have 1x plus 0y is equal to -3, so that's going to be x is equal to -3. And so that is our solution, -3 and -2. Now we can go ahead and check that in each equation. So if I check the top equation there, we have x is -3, and then we're going to do -3 times y. Y is -2. So we have -3 minus 3 times -2. So you have -3, and then you got the double negative, so that becomes a +6. And so that's equal to 3, and that's what the right-hand side of the equation is. Now let's go ahead and do the second equation. So we have 3 times x is -3 plus 5 times y, which is -2. So that's going to be equal to -9 plus -10, and so that's going to be equal to -19. And so this checks out, so this is a good solution. So if we were to graph these lines would intersect at the location -3 and -2. All right, well that's it for this video. We'll see you next time.